welcome. Thanks for coming. I had a plan with this abstract I submitted, and I kind of went through some phases with this presentation. And where I landed was with sort of this barbell strategy, which is a concept I'm stealing from Nassim Taleb, the philosopher and angry, opinionated ex-Wall Street trader guy who wrote The Black Swan, which is I kind of go into the real like nitty-gritty, super accessible examples of some software engineering violations to explain why I think this UI separation of concerns is totally legitimate and totally valid, and you might want to give it a thought. And then I talk about some high-level behaviors, sort of referring back to the MBA framework, which is a control systems open source separation of concerns framework, but nothing I'm saying is specific to that framework. Nothing I'm saying means you have to use any of our tools. I'm just kind of trying to prove a point without coming off as being a super negative jerk. All right?
Have that problem.
And warning, there might be pictures of mullets ahead. I'm Ethan Stern. I'm a managing partner at Compose Systems. I was one of the first few members of the company. And 2-ish years, 2.5.
Wow.
It was a sort of, I'd say like a bootstrapped kind of a start where the company existed before I joined, but we didn't really do anything, and we built it up, one lucky customer at a time. Lucky for us, and I guess they were lucky too, if I'm going to be a little bit arrogant. So I like working with my team. Working at Compose Systems is awesome. Everyone really kind of knows why they're there, and we really like writing software and talking about software and code reviewing each other's stuff and sharing new ideas, and it's really kind of, it's been an awesome transition. Once we made it, we never looked back. I like manual transmissions. I obviously like presenting at the CLA Summit because I'm doing this again in the next hour. I like heirloom apples. It's a fun fact. And I like software with consistent semantics, which might be a theme of yesterday's presentation and today's. So what do I value? All of the stuff that everyone values, the composition, robustness, aesthetics. We're talking about user interfaces. I was really tempted to raise my hand when Jim was like, does anyone care about user interfaces all of the time? Like, actually, yeah. Like, there's a context to it. If I'm making a test panel, like, it doesn't look like a pile of crap. Like, it looks like a test panel with clear, obvious buttons. Because even when I start to get to button matching, like, if things aren't associated properly on the screen, like, I'll do stuff that I never meant to do and go, I forgot I had to enter that value. Like, yeah, I kind of always care, but there's a context. And the itties, usability, testability, is like, well, what does everyone value? Maintainability, scalability, usability, testability. Like, these are all the same thing, really. Like, I mean, you can't, it's like the solid principles. If you absolutely nail single responsibility, I guarantee you did a damn good job of the other principles, right? Maybe not this guy. But you can't really have one without the other, so. All right, G Package Manager, has anyone heard of it? So I said, I'm talking about my framework indirectly. If you're interested in it, the thing John McBee presented earlier uses the framework to do the CLD car wash. We had a little issue realizing at the last minute that when you pull it down through GPM, it's broken, and we're working on that. But hey, this is like that collaboration thing that we always talk about doing, and we're like, as a community, we need to get better at it. I don't know, some jerk said that at the last CLA Summit. And like using G Package Manager and working with Derek on it to kind of explain our use cases and make the tool better has been another thing that's pretty cool. We're using a tech stack of a lot of open source stuff that we've written that follows the solid design principles, and we love deploying it on a by project basis. So customers can choose to check in the actual source to their source control system and not have it depend on some mysterious version that lives in user.lib. Or we can be lean and light, and we can just rely on the package configuration file that we check in next to our project to say when I pull this project onto a fresh VM, I just run the GPM install command and it like updates all my stuff with the stuff from the GPM repo. So as I said, we're working through a couple glitches with our weird and complicated tech stack with examples and maybe a continuous integration tool we accidentally put in as a dependency.
Yeah.
All right, cool. So solved. Sure. We'll solve soon. And you know, this is how you go to gpackage.io if you wanted to look up this framework. That's how we look it up. We have a namespace, we have a package name. All right, let's play a game. I need you guys to play along. Should a UI auto-scale everything?
Well, all right, UI should auto-scale everything. You shouldn't check that checkbox. You should auto-scale.
Applies to only to single panels. I love asterisks under checkboxes. Context is everything here. That's kind of the point I wanted to make, which is like, what the hell would this button actually do? Like, if I shrink my thing down to 2 pixels, like, how should it behave? Like, should the font sizes change? Like, obviously there's almost every element on the UI is going to have a different minimum size, but it might be a different minimum size relative to its original size, and splitters and all of the stuff, all the complex stuff that UIs do. This is a ridiculous button, right? So you can write something simple, and you can, you know, oops, like 3 resizes later, it's like it's unusable and it's unrecoverable until you close it and reopen it, right? So this is a ridiculous idea. We shouldn't actually expect this to work. It's like auto error dialog boxes. It's like a terrible idea. The person who implemented that probably doesn't work at NI anymore, I hope. Anyway, it's fine.
There are people at NI that argue that that's a good check.
Yeah, marketing people. I'm told it's always the marketing people who think that's a good checkbox. All right, so it's a pie in the sky. It's a ridiculous thing. We don't expect our business logic to write itself. We shouldn't expect our UIs to write themselves and define all these complex rules about scaling and sizing and appearance. It's ridiculous. All right, I warned you. Should a UI be tightly covered with business logic? Sarcastic, definitely. I hear some no's. Who makes an effort, like a deliberate effort, using some kind of pattern that they know to separate business logic from a user interface? Cool. I'm pretty interested in how people do that, because you know the framework that I mentioned is the way that I chose to do that, but it's just one way. Should a UI affect testability? And I maybe have to explain my angle here. Right? When you design UI down, when you have a big monolithic user interface with all your buttons and knobs and stuff, you start placing stuff behind that in a way that just kind of clicks together in a not arbitrary way, but you're not thinking about test first, right? Like I should be writing my modules and just testing them and then like plugging them into some kind of business logic execution model or VI. And my UI should just be a different thing altogether. And you know, all the code we all wrote in year 1 of our career, like you couldn't unit test it. I mean, that's like, you think back on that stuff and it's laughable. But there are a lot of people who kind of stall out there. And it's like, well, you know, we made a proposal to this customer and we showed them a UI. And then we just started like putting blocks behind it to make it work bit by bit. And that's not an awesome thing to do. Should a UI be monolithic?
If it's
If it looks as good as this guy.
Oh, yeah, it's small.
Yeah.
I mean, it's lots of sheets, yeah.
If it's small, like that silly example I showed, right? A chart, a few buttons, like,
Yeah.
let's not overcomplicate things. The dialog box, right. But in general, like, right, composition over inheritance, but like, composition is generally a good thing, right? So when we can decompose something into smaller bits, we can make reusable pieces, and we can actually make those reusable pieces really good and actually reuse them. Should it always exist? You probably can't see this, but there actually appears to be, this is my favorite photo that I found, obviously.
Did you have to have proper browsing on here?
Yeah, this is what incognito windows are for. Sexy picture of man holding oxen. There's actually a string apparently holding that dog up in the picture. You probably can't see
It's
that.
Wonder Dog. It's obviously Wonder Dog.
What we want, yeah, obviously. I'm so uncultured. I mean, not a David Hasselhoff fan, I guess. Should it always exist? No, like when you're an actor and it's a business logic actor, yeah, it has a UI because that's how LabVIEW works, right? But it's got the terminals for inputs and outputs, and the only way we can get stuff in and out is by assigning those to the terminals on the little connector pane. Like, okay, we have to have that, but we don't actually need the UI. Is my.
How about you take exception to that?
Okay, look, we're going to talk more about this. I'm glad you're interested. So let's talk about one reason to change. Single responsibility principle. I already just told you what it means. It really means one reason to change, right? It doesn't mean like I have two buttons and I click on both of them and, well, maybe I want to change the font on this button and leave the font on that because that's really good style. That's two responsibilities. That's not what that means, right? It means that if I'm going to well, let me look at my own slide. So first of all, which is more inclusive, a class or a VI? I warned you, we were going to go like nitty gritty on some things here. A class, it includes more, right? And class includes a private data cluster and multiple VIs, which we refer to as methods, because that's conventional. So a class includes more. So if a class should have one reason to change, then a VI should almost certainly have one reason to change, because it's a more granular piece of software. What are vectors of change? Where I said one reason to change. Vectors of change, would anyone care to answer, either generally or specifically? When you're talking about agile development and vectors of change in that context, vectors of change is referring to the things like spec documents or new user requirements or managers changing their mind or like new stakeholders or hardware that goes obsolete. Like these are the things that drive changes into our software and make us have to redesign things or refactor things or override things, right? If we got the design just right, we can just replace this object with that object. So that's the idea. That's sort of the impetus for this whole thing. And this is just in general, because if you don't really understand this principle, you're not comfortable thinking this way, what are some common responsibilities that we abstract around? Like if you follow Solid, are there common abstractions that you create in your applications or maybe GPM open source packages that you released that abstract around certain specific responsibilities? Anyone?
I'm still like ankle deep in Solid, so.
Okay, well, just plunge right in.
Yeah, I mean, it's good temperature, but, so like I would create a module for one resource, and then one module for kind of like some business logic, which creates interlocks to make sure that this digital output doesn't go high when this analog input is.
Okay, well, I mean, that sounds like modular design.
Yeah.
What I was trying to suggest here is things like persistence, right? Paul Ross, my colleague, is going to present his totally badass event logger tomorrow afternoon after everyone's already gone home. And it has a persistence abstraction, which allows us to say, write our software and log it to a text file like a normal event logger, but also log it to a networked instrument on the other side of a local network, or log it to a database, right? There's an abstraction around persistence. When I log these events, where do they actually go? So I can look at them and look them up later, right? That's a common responsibility. Transport is a responsibility that we've defined that's sort of a common abstraction in our applications. The NBA framework uses it to abstract, well, when a mediator publishes something, how does it actually transport that something to the user? It's totally different depending on whether it's transporting that to a model or view, so that's a concern. Disk persistence, I think I put some examples of common responsibilities in my slides, but I don't think any of them. So, persistence, business logic, you can write abstractions around business logic, right? If you have a logger, maybe it filters events, right? So you could write an abstraction around the logic of, well, how do I decide what is good or what is bad in my Right. Are these things coupled? I have a VI that has a little event handler. This is an awesome VI with some buttons. You only see one button.
Yes. Yes.
I mean, it's almost a trick question, right? Because the save button and, well, it's one file. Like, coupling is talking about the interrelatedness of modules, right? Like different software modules. In LabVIEW, we have this like sort of crippling idea of a front panel and logic all the time everywhere, right? So like they're so coupled, they're almost not, because like it's not a valid question. They're the same thing. So here I have the style of presentation and event handling of my button coupled to the file format. Like, not a great idea, really. All right. So this idea and the one that follows is from Rich Hickey. He is the creator of Clojure, functional programming language. He's also the benevolent dictator for life of Clojure. So he talks a lot about how reducing state, how in functional programming you tend to reduce state. I suggested yesterday in my 7x7 that LabVIEW is basically functional programming. Right? Data flow is functional programming. You have immutable data coming in, going out. When we can reduce the state that these things depend on, it's easier to understand them, and it's easier to understand their responsibilities, and easier to reduce their tendency to have bugs. I was trying to say that like in a politically correct way for some reason. Complecting. So this is another Rich Hickey concept that John McBee introduced me to by sharing this video, Simple Made Easy, where he talks about complecting as interweaving the concerns of your application. Right? Complecting data like this is frustrating. I'm an actor. This is an actor, by the way. An actor's private data. And it's got state data and a compositional class and ref nums it uses to modify state of the user interface. It's small, but these things don't stay small when you write code this way. They start growing. Do you guys know any swear words? And sometimes single responsibility is so easy. This is, I stole this out of last year's slide deck because I didn't want to look at this code ever again. This started out, I think, as a test panel that I wrote for the customer, and it was like, well, we have this old legacy thing, and it does all this stuff, and it was like, I was like just adding functionality one thing at a time. We just built up this ridiculous cluster of ref nums. This was like the framework registering for all these things and binding all these things. Sometimes
live in the field right now.
Actually, this has been obsoleted. Yep. Wait. We put our foot down sometimes. It's actually a very smart customer, so there wasn't much pushing required. Sometimes sheer volume is enough to know that you're breaking SRP. Right? There's way too much going on here. And when you decompose those problems, you end up with cool stuff. Like you can spend a couple hours writing an abstraction around a multi-column list box that auto-scales column widths and like can do, you know, that dark light pattern thing if you think that's cool. Google probably doesn't. You can make things pop in and out of Rails and, you know, out of subpanels. You can make all this stuff and then just reuse it. You can invest in these bits, you know, like Jim Kring and JKI invest in making buttons that look really cool. You can invest in making slightly more interactive things that look and work really cool and not have to create them again. All right, so in concluding my section on SRP, you know, what is a UI's responsibility? I think my main point here is that UIs don't get a free pass in terms of the solid principles, as we often act like they do. Display is a responsibility. We've had real situations, actually that same redacted email that John put in his presentation earlier of the crazy company owner emailing him at 3 in the morning saying he couldn't sleep. I wish you guys could have read that because the email is just priceless. At one point in that project, they were like, we'd been given all this bad information by the middleman about what the UI needed to look like and how much the customer really needed it to look exactly like this. So I was like cranking away on making the user interface work exactly that way and use all these crappy X controls. And it was like, I don't think this is actually good, but this is what they want. And then as soon as we delivered it, the actual customer was like, so how hard would it be to replace all of this? Because we think it looks really dumb. and we got to say, not that hard. So that's a real thing. I'm sure you guys have experienced it. And like property nodes and UI threads, slow stuff, like just keep that away from business logic. It's a good idea. All right, so let's talk about dependencies. Probably, I think I know this crowd a little bit, and we'll probably go pretty quickly through the section. DIP. A software entity should depend on abstractions. It's like against my religion to say concretions out loud, unless I'm explaining that I don't say that word, in which case I can say it. Concretions. It's just too jargony for me. It doesn't matter whether you are using classes or object-oriented design or actors. Like, this principle is 100% valid, as actually are all of the same principles, even if you're not using classes. And if you write LabVIEW and you don't follow DIP and your project gets really big, like thousands of VIs and LV libs and maybe some classes too, you open the project and it like takes 10 minutes to load. I've had plenty of customer code bases which I fortunately left behind that operated that way, and they couldn't fix them because so-and-so said something, whatever. We were talking about incompetent customers earlier. So, load times, IDE responsiveness. Fun fact, Stephen told me earlier, bless you, that he fixed the right-click class properties slow loading issue. Who's ever right-clicked on a class to edit, modify its class properties, like its inheritance, and it takes like 15 seconds and then the IDE times out? Apparently that's fixed. So
that's why we download the toolkit. We're never have to do that. We're not the only ones who.
Yeah, but also there's another. That was a symptom of another problem, and that problem cropped up when you had dependency loops. So it's almost like bad that he fixed it, because that was a clear symptom that you have dependency cycles in your code. Okay, so IDE responsiveness, load times, build times. We've had things that took 45 minutes to build where you fix the dependency loop and it takes 15 minutes. Like, and I was talking to Stephen about this earlier, and he was like absolutely amazed that we have this problem and said that shouldn't be. So top men are looking into it. Yeah, and like, well, I know, maybe don't fix it because it's an incentive to not suck. Anyway.
We have to be more.
Know that you're sucking. So pop up the file and say, write your code back.
Consciousness is key. Yeah.
When the LabVIEW team transitioned from LabVIEW 7 to LabVIEW 8, they went from this basically just VIs with no way to easily get between things to a project where you could do things with the IDE that you just couldn't do anymore. And in the process of doing that, they found all sorts of these order in, order into the end. I even found an order into the end to the end problem that had been buried in LabVIEW for years.
That's why we're all so pumped about NXG. We can't wait to use it as soon as they release 4.0 or whatever.
Next lab.
Well, suppose that current gen LabVIEW has the IDE has a major problem with dependent objects. So if you have more than like 3 layers of dependency on anything, like you have a reference to a reference to a reference, or a cluster to a cluster to a cluster, and if you change a part of it, there's no guarantee that the last bit of it is going to get fixed.
Changes propagate through. Like
Yeah, the changes will propagate through correctly, and this shows up most especially when you're using classes and using property nodes to access the class elements. They don't update in property nodes. So I just stopped using it. It's supposedly go on in next.
I believe it. I was talking about how they're linking in next gen. It's like, oh, wow, that actually makes total sense. Like you guys thought about it from the beginning. That's awesome. So you can get away with sloppy design if you follow SRP. This is real code. This is deployed. There's sort of a multiple owner problem here where I wrote something. I was like, this is a little big. It probably needs to be refactored. And then the customer added some more stuff, and like it works. But there's no dependency loops here because I'm depending on abstractions. I inject the actual object types that this is a real-time system, that the real-time system is going to run. These are actors. And then it launches the actual types. But it doesn't, this model does not depend on concrete stuff. It depends on abstractions.
Say waffles.
Wow, good eyes. Yeah, I redacted some of the information just to make sure it didn't, and it was not domain specific. It says waffles. I think there's something that says laser blasters down there too.
Oh, I missed the laser. Well, there is laser blast.
Okay.
Nice.
Now I'm really glad I did. Okay. So very simple example where we run through the dependency problem. All right. So I have these two methods, or VIs. I guess one of them is a method because it's in your class, and one of them is a VI. Whatever. Methods. I don't say VIs anymore. One acquires the voltage, one processes the voltage, one outputs this type def, one takes that type def as an input. Right? This is what it looks like when you call them in sequence. Cool. Functional programming. Awesome. Notice the DAC type is a member of the DAC thing, LBLib. Don't ask me why I made one on library and one class. It just made the example more confusing. I think I was going for inclusion. Like maybe you don't use classes. All right. Who depends on whom? And I said, I'm calling them people because the language makes a little more sense.
Yes.
Data processing depends on DAC thing because it has an instance of DAC thing's type def on its front panel. Correct.
Yes.
And Sarah presented on it. So like during Sarah's keynote yesterday, it was like she kind of explained this problem, and I was like, damn, she's stealing my thunder. But also spot on, right? So, okay, my application is kind of getting out of like test bench land, and I now have an actor, bipolar tester, who now depends on data processing, right? I'm using composition. My actor sort of defines some asynchronous behavior. It's composed of a data processing object, which actually does like the hard math behind the scenes that adds A and B together using the add node. So now I have data process, bipolar tester depends on data processing, right? Because it has it in its class data, which depends on DAC thing. So now I know that bipolar tester depends on the DAC thing because those relationships propagate. And note, bipolar tester defines this cool control, because it's a bipolar tester and it's a user interface actor. So it defines this enum that lets me like pick which polarity, A or B, which is totally awesome real world example. And then I'm like, well, actually, my data acquisition could like know the polarity at the beginning, and it should know for the measurement because it does something. And I put that type def into the DAC thing method. And now I have data processing depends on the DAC, and the bipolar tester depends on data processing, and the DAC depends on the bipolar tester because it's calling its type that it defines. Right? So I have a circle. That's not good. That's not solid software. Ever. It's terrible. You should all be ashamed of yourselves. Like, I was writing active framework for a long time before I realized like exactly what this problem was, and exactly how to solve it, and exactly how important it was to solve it all of the time. So it took a lot of suffering to get here. Exactly. Suffering is really almost the only way to learn.
You could be wrong.
All right, so it's super easy to create dependency loops. You actually only need 2 modules. You don't need 3, like my example. These are not errors in LabVIEW. They're just bad software design and implementation. Mixing UI with business might encourage this, and I'm going to show you maybe why I made that statement next. Types, type defs or classes, right? Private data clusters are vectors of contamination, but it's not just that. Obviously, if you're calling anything that library defines, whether it's a type or a VI, or X control or whatever, it's going to create these relationships. A great example is active framework messages, right? I have 2 actors. This guy says, I have these 3 messages, and this actor has 2 messages. And this actor sends this guy one of his messages, and this guy sends him one of his messages. Those are coupled. They're calling each other's message sets. So if I load this actor into an empty project, this one shows up too. And if I load this actor into a project, that one shows up too. That's a dependency loop, and it's very easy to do. And the way I would solve that problem if those actors really needed to be designed that way is to put them in the same library. because you're saying, hey, LabVIEW, compiler, and programmer, these things belong together and they can't be separated. Yes, there are two asynchronous actors that can do asynchronous work independently, but you can't have one without the other. Right? So that's a practical solution to that problem.
The AI group actually has a process that runs every night and checks for dependencies, does a dependency walk in the entire group, make sure no one's put something like this in.
So we've written some tools, and I'll give you just a second. We've written some tools that look for cyclic dependencies or notice them, and we've been talking for a long time about having like just a little daemon that runs in the IDE, like project provider-y kind of thing, where if you create a dependency loop, it barks at you and says, yo, you just created a dependency loop. I think that would be extremely useful. I hope NXT does that.
In terms of what you're talking about there with two actors that are using each other's messages, are you saying that it would be better to combine them into one actor, or is it enough to take both those actors and put them in a higher level library that contains them both?
It's a good question, and I think it shows your understanding the conundrum. It depends. You very well might have designed two actors who need to be asynchronous and do asynchronous work in parallel to each other, right? That is sort of the whole purpose of an actor. It's a code smell if they're constantly direct messaging each other, and while they're doing that, the other one is idle, right? Like if this guy does something and then hands the responsibility to this one by sending him a message, and then he does some work and he sends a message back, totally make it one actor. That's, you know.
Like two independent that are doing things.
But if they're both busy a lot and highly asynchronous and they just use these messages to sort of queue work or information to each other, then yeah, put them in the same library.
But does one have a bigger effect on IDE performance than the other?
I don't think that either one of those would slow down the IDE. My experience is when you define, and I talked to Stephen about this, he was totally perplexed by everything I'm telling you right now. You can slam the door on that problem, whatever is actually causing it in LabVIEW, by putting them in the same LV lib. So you don't see the IDE slow down and the build issues and the weird dependency linking and stuff when you do it that way.
I'd like to talk to you guys more about this at some point.
Yeah, come see me anytime, except in the next hour.
Yeah.
All right, so, what time is it anyway? Got some time. I think we're good. So I have these classes or libraries, let's just say they're classes, and they all have some stuff that they define, like maybe those are type types or methods. Well, for this example, they have to be some kind of types. They have to be something I can put in a cluster, because I've given myself a cluster box. Because remember, we're talking about user interfaces. I have to remind myself. Because I don't see the domain specificity of user interfaces and software. I see software, and that's what I'm trying to get to, or I'm getting to. All right, so let's say I put this type into the cluster, and then I put that type in the cluster. Notice the cluster, these are UML depends on arrows, close enough. All right, so the cluster is starting to depend on these things as I put their types into the cluster. So I'm aggregating all these dependencies. Now this cluster doesn't just depend on the fish, the crab, the tortoise. It actually depends on these libraries, right? So if I put this cluster into an empty project, it's going to pull all of these libraries into memory. You're like, okay, well, but it still follows dependency inversion because like they don't really depend. There's no dependency loop, let's say. I think that's a safe statement. Until I put the cluster into E because maybe it has a UI or something or a front panel or it just needs to do all this business in the cluster. Maybe I don't know how to write software. Maybe someone else did this. And now that's dependent on the cluster. And I have this loop where class E depends on the cluster and cluster depends on all the stuff. So it's a big messy loop, right? You're like, well, I would never do that, right? That's just an idiotic thing to do. But would you ever do that? Would you ever put all the types on a user interface? It's the same problem. Now the user interface aggregates dependencies when they're strict types, like type types. It is a thing, it is a software entity, it's a VI, and it depends on all that stuff. Right? So if I ever depended by any one of those classes on anything that was in the UI's library or on the UI itself, like I have this dependency loop. So maybe you shouldn't do that. My experience is the cost of these mistakes is high. I'll tell you a super generic anecdote, but it's entirely true. John was working on a complex project, big project, a lot of code, high abstraction. And we brought in like a developer to the project who was very new to the active framework and abstraction in classes in general. He was smart, but he didn't really know his way around. And within like 1 day of developing, the project was so convoluted in terms of its dependencies that you couldn't open it, like things kept crashing, it took like an hour to load. Obviously you couldn't build it, it was like a total disaster, and John had to go in and like kind of groom out all the problems and figure out what the heck caused this. I mean, was it a perfect design? No, this was many years ago. But you know, the costs can be really high when it comes to build times and just difficulties with the environment. And non-dependency inverted software is straight up not modular. You can't reuse it. Let's talk about composition, which we all already value over inheritance. All right, so I think I maybe deferred a question earlier, or this guy in the red shirt. What's your name?
Yes, Brian.
Brian?
Yes.
I think you were saying maybe you disagreed about something about actor UIs.
Yes, I did.
Okay, so now we're there.
I don't remember why I did.
All right.
So,
When you're designing your actors, right? Actors are abstractions, they're classes. They encapsulate some functionality and some data. They expose some methods and they invoke those methods by having messages. So when you design your actor, it has a UI. Do you design your actor around like, well, what do I want to see in this sort of like micro application that's running on the UI, and then I make that actor do all that stuff to produce that data and collect those inputs from the buttons I'm pressing? Or do I design my actor around, well, I have this instrument that's a DMM or something. I hate DMM examples, so I shouldn't use them. But you know, it does some, it talks to some instrument, and I just say like, I'm going to make this actor do all the stuff that this instrument needs me to do, and then like I can make that actor have a user interface that only exposes what that instrument can do. Which one of those is good?
well, would separate them.
Ah, that's a good idea.
What I would be doing is subpaneling the actor or the instrument into the frame so that you get a nice. So I think normally you have these are VIs, they're virtual instruments. Make virtual instruments on top of what your actual instruments are.
I think you're making a case for separation of concerns, where like you want to think about your UI and your business separately. Cool. So I thought there was a.
I just showed the terminology.
Yeah. Well, I'm learning terminology every time I come to the CLA Summit.
Yeah.
Use swear words, all kinds of good stuff. Yeah. Well, hey, I didn't know about Jim Crank's new palettes, so excuse me. All right. So I'm just gonna walk you through like the inheritance, actor inheritance UI problem, right? Because like when I started using the actor framework, I sort of designed around. I designed around the functionality of the actor, and I was like, well, the UI just kind of emerged. I got what I got, and you know, okay. I mean, at least they're modular, and I can like put them into subpanels and stuff, right? I can still assemble them in a way. So I have actor A, and then okay, actor B is like a new subtype, right? It implements something slightly differently. It's a different kind of instrument, and it like works mostly the same for a while. So it can implement some business, but then I decided, or I realized. Oh, it needs some additional UI special sauce. It needs like a slider, something really cool. So I now have to re-implement the whole user interface for that actor because I have inheritance, and inheritance is rigid and kind of leads to code duplication when you don't have things like interfaces. Right, so I can't just use the part of actor A's front panel that I want, because actor A and actor core and the front panel are one thing, right? So when I override actor core, maybe to do something differently, or I want to extend actor core by adding a piece, I add it to actor B, I have to duplicate all that. So maybe, yeah, it's dirty. Makes me sad. Right? So I'm like, oh, cool. I understand these class things, and I've heard of Solid, and I think I understand it, and I'm going to be really clever. So actor B appears, and then I go back to actor A, and I add this extra thing. Which Solid principle am I breaking here? I'm breaking something other than SOP. I introduced a subtype, and then I had to go back into the ancestor to edit stuff. Open close, right? Actor A should be closed for modification and open to extension. So actually, the previous solution of duplicating the code and rewriting a new UI that kind of did all the same stuff but added something is better. I mean, it's better. This is worse, in my opinion. Right? Because now actor A has to like know actually which type is running on the wire and be like, oh, I'm running in actor A mode, so I hide this vertical slide. Like, it's no, not good. Also makes us sad. So what does a composed user interface look like? For starters, forget that you have front panels on those actors. Build some UI components, and then have those actors descend on the parts that they need.
What an X node is?
Is that what an X node is? No, not exactly.
That's what X nodes is. I mean X controls. Are you in X?
X control.
Sorry, X controls.
But an X control is not a user interface. Really? It is.
X controls are okay, is what it is.
Yeah, X controls are a piece of shit. Just saying.
Absolutely user
Yes,
interfaces.
they are user interfaces. They are like little dumb actors with really weird APIs. Yes, I'll admit it. I don't want to give any ground to X controls because I think they suck.
They seem like a really good idea until you try to use them.
Yeah, good idea, bad implementation, and very limited in like flexibility. No extension, right? So, did you have a question?
No.
You didn't want to say you like X control, I do.
I did. What I do. Well, you need to just get out.
Yours over there. No.
Computers are getting faster, that's all I can say.
I love the memory is cheap argument. That's one of my favorites. Yeah.
Just throw more hardware. Simple bit.
So,
what do you think so fast?
no, joking aside, X controls were a legitimately good idea. I think the implementation is very clumsy,
Yes.
and I think we have way better tools and techniques available to us now. X controls have their place. They definitely had their place, and I think they're useful. So, I don't use them though.
Did that hurt so bad?
Remember that project I told you about where the customer immediately asked us to scrap the whole UI? That used X controls.
PTSD thing.
Thank you. Yes.
There's a sport word for that.
This is composition. So I made this slide at the last minute, can you tell? Because Dimitri was talking about this concept of humble classes, right? And so we do innately have a concept of a block diagram and a front panel, right? We always have that in current gen LabVIEW. I don't need to actually divide the routing of events, the handling of events, right? I can keep my UI super thin. My front panel is where I define what my front panel looks like. And in Dimitri's presentation, he was talking about kind of having a class for that. My block diagram can like register for the events or catch them. And that's the testable part, right? I can actually even test that if I have event filtering, like direct event responses in my view. You kind of just get this by using separation of concerns with actors where you have a front panel and a block diagram in actor core. So like a little light bulb went on and I just thought maybe I'll mention this because it ties back to an interesting concept. And I'd never really thought of it that way. All right, so I've told you all this computer sciencey stuff, and we've talked about solid begrudgingly maybe. So I was like, you could just make these widgets and have this depend on that, this depend on that, and use the pieces you need. But you need some glue to hold that together, right? So that glue can take many shapes or forms. You can implement this in many different ways. But if your application is going to make sense and be sane, you're going to need to have some consistent semantics. So the thing in the MBA framework that I call viewable, it's one of those legacy interface classes, pre-proper interface in LabVIEW. I totally lost my train of thought. Jeremy, yeah, time.
Yeah, you said a couple.
I'm wrapping up. Oh, it uses mediation, right? A mediation mediator, observer pattern, to get data into the views. Right? So when a view starts up, I just have an API in the framework. This is, I want to bind this to this, this, and this, and this. And then views are abstracted from the things that are producing the data. And then when I'm pressing buttons on those user interfaces, I have a little other section of the NBA framework view API that lets me propagate those up to the view model to get processed or filtered by any view above them in the hierarchy. So I have these rules. You can't dependency inject stuff into the NBA framework that's going to break it. It just won't work if you don't program it correctly. So there are semantics that are required. It doesn't mean it's the Wild West where you can do anything and it magically glues itself together. So let's just look at a couple of examples, right? If I'm separating views into VIs or actors, I'm separating business logic into another place, I can use this pattern of having a mediator. The implementation in the MVA framework is a little bit more complicated. There's topics, as Dimitri was talking about earlier with his message bus, and there's a view model, and the routing's not quite as simple, but this is entirely the idea. This is all you need to understand to use it. The UI subscribes to something, it tells the mediator, and when you launch it, hey, I want this, publisher publishes it, it shows up in the UI. Right? That's how the observer pattern works. This is how do UIs produce events that actually generate meaningful work, right? Because we've put a brick wall between them and the business logic. A model, in this case, something that's doing business logic, subscribes, just like a UI does. It says, I want to know when this Boolean go happens. Tell me about that. A UI generates that, and it hits the mediator, and it goes to the model. The model does work. What if I have real abstraction or nesting in my user interfaces, and I have a UI that spawns off a nested UI? So it's like, maybe a button panel and then a chart, and that's two separate things. And I do something in the chart. Maybe I can press go on the chart. Not a really good example. Right, but the nested thing generates an event. Well, it just gets routed through its caller up to the mediator, to the model who subscribed to it. Right, so there are semantics and rules of how this actually comes together and functions constructively, but none of it's magic, and none of this, I didn't invent any of this, I just implemented it. And at the very end of the day, what should your UI do? If you're in main.vi mode, your UI does this, right? It aggregates and defines all of the control and all of the dependencies and all the relationships of your software. In my software, I have a VI whose job it is to dependency inject the actual runtime stuff that my application's going to use. This is our assembler. Sometimes we call it the assembler launcher because it assembles all the stuff and then it launches the root actor of the actor framework, and MVA does all of its magic with mediation. So that's pretty much the end. There's no exception for user interfaces. Dependency loops are the worst. You can really do modular UIs. If you want to be my pen pal and email me about how I do it, you probably can figure out how to get in touch with me between my email address that's on a bunch of G packages and Bitbucket repos, and also just talk to me. And there's stuff to do this. There's so much you can learn from Google and MSDN and, dare I say, Stack Exchange about separation concerns, patterns, the observer pattern, and our framework's available with soon-to-be working demo of the CLD car wash. It's John Newby's fault, as usual. The black sheep of Compose Systems.
Yeah.
So thank you for your questions, your interaction. Does anyone have anything else?
What tool do you have to find loops? Because it's like really easy to make loops.
So we don't actually have a packaged tool to find loops, but I was talking to Steve Ball about this yesterday, about, we should really just polish this thing up. And he said he already does it in his dependency sorter that we...
Yeah, I saw that.
Yeah. So he's done the hard part, I guess, the algorithmic part of finding the dependency loops. And we just need to get that information to the user's eyes.
But we spent all yesterday trying to get this built into work because there was bullshit loops. And the only way that I know to fix it is you create a blank project, You drag the top level guy in, you drag all the acceptable things in, and then you look at your dependencies list and say, why is this dependencies? And you have this not very helpful list
Why
of
is
things.
this?
So look for a package very soon that tells you where your loops are. And you might be terrified.
I think at one point I solved by every actor had its own project on with it, and I just dropped the actor in there and see what depended on it.
Honestly, if
That's
you
not a bad
really
way to
want to make sure that you're doing it for real, if you use PBLs. Like, you can't really do circular loops
Packed project.
in PBLs.
Oh, no,
And so it's like, it's game on, you're doing it for real.
This is why people hate PPLs, is because they make you follow a dependency narrative. You don't have a
After
choice.
doing my first big PBL project, it was like, oh, I've been screwing this stuff up.
Yes.
Yep. But we all learn a lot by sucking sometimes.
Yes.
Feeling that pain. Eating your own dog food or your own cooking is an important part of growth. So, I mean, we're done, so you're giving me that look.